Welcome to clickmyproject.com. Yeah, now let us discuss about the Microstrip Sierpinski carpet antenna using transmission line feeding. Yeah, let us discuss about the abstract of the product. So the technique of the subdividing a shape into smaller copies of itself, removing one or more copies and continuing regressively can be extended to other shapes. So for instance, subdividing an equilateral triangle into 4 equilateral triangles, removing the middle triangle and regressing leads to Sierpinski triangle. In 3 dimension, a similar construction based on cubes produce the Sierpinski spunkage and Mensch spunkage. So in this proposed work, a novel design fractal antenna designed a square patch antenna. So the square patch antenna is used to operate multiple frequencies between 1 to 12 GHz. So fractal antenna design technique is used because of its self-similar and space filling property. So the area of the proposed antenna, it should be reduced by using the square patch antenna of the process. So here we using the substrate is FR4, that in case dielectric constant is 4.4 mm, and then the thickness of the height is 1.6 mm of the process. And also here we using the microstrip feed line process. Here we using the feeding as a microstrip line feeding of the process of Sierpinski algorithm, using the process of the major activity to algorithm of the process. Here we using the 5 iteration of the process. So the microstrip antenna basically consists of a radiating patch on one side of dielectric substrate which has a ground plane on the other side. So the patch is generally made of conducting material such as a copper and gold, so the patch is very thin. The different radiating patches may be square, rectangle, thin strip, circular, elliptical, triangle or any other configuration. So the radiating elements and the field lines are usually photo etched on the dielectric substrate. So the microstrip patch antenna is a low profile antenna and has a number of advantages over than the other antennas of the process. So the radiation pattern, directivity, return loss, VSWR and bandwidth of the proposed antenna are calculated by using the HFSS 13 software package. So HFSS is a high frequency structure simulator. Yeah, let us discuss about the flow diagram of the process. So this is a HFSS there. So general process of HFSS, so generate a 3D structure X, Y, Z axis and then solution type. Here we using the solution type. There are 2 solution type, one is a driven terminal and another one is a driven model. So here we using the driven terminal of the process and then parametric model. So the parametric models consist of geometry material, one is the boundaries, another one is the excitation of the process, and then analysis setup. Here we using the solution setup or frequency sweep. So analysis setup, start and stop frequency, and also here we using the transfer frequency of the process, and then result of the structure. Finally we calculating the return loss, radiation pattern, VSWR, bandwidth are calculating by using the HFSS software. So here using the parametric model like a sandwich type of patch antenna. It's like assuming when using the, so generally patch antenna consists of 3 layers: substrate, patch, ground. So substrate in the middle layer, patch in the top layer, ground in the bottom layer. So the substrate is sandwiched between the ground and patch, and it forms a patch antenna dielectric medium of the process. So this is called a patch antenna. So this is the side view representing of layers of the antenna. So this is the patch and ground and then substrate. So these are the basic concept of the substrate of the antenna. Yeah, this is the antenna design model. First of all, this is the first iteration, and then this is the second iteration, and then this is the third iteration, and this is the fourth iteration. So these are microstrip Sierpinski process of the process. So easily to calculate to increasing a multiple frequency and also a bandwidth of the process. So boundaries, here we using the boundaries, the perfect T, that is the electric field is applied to the patch and the ground, and then excitation, here we using the wave pole and then lamp pole. By using here we using the excitation of that reservoir wave pole for to excitation of the process. Analysis setup, here we using the 1 to 12 so GHz of the process, generally calculating the radiation pattern, return loss or multiple frequency of the process. So these are the overall flow diagram of the HFSS software. Yeah, let us discuss about the running procedure for the process. So this is the HFSS window. Here we using this 3D axis. We using the design to whatever it may be. Its design should be easily to draw by using the these are the different type of square, circle, pentagon. So these are the different types of patterns in 2D dimension. So these are the different types of 3D patterns. So here we using the Sierpinski diagram for optimize. So here we using the 5 iteration of the process. So I will open it. This is the one iteration, again this is the two iteration, this is the third iteration, and this is the fourth iteration, so the first iteration. So these are the 5 iteration of this process. So I will, using the boundaries and excitation, I will click perfect T1. So I will click the perfect T1, that is should be electric field passes through the patch, and then perfect E2, this is the ground of the process, and then radiation, I will click the radiation of the process. Vacuum boxes should be done by using the electric field of the process, and then excitation, so in the excitation process, and then using the circle by using the process of waveport analysis of the process. So here we using the waveport by using the rotating condition. So this is a waveport I will apply for the feeding of the process, and then analysis. Here we using the analysis setup. So this is the center frequency, so I will click this 10 is the center frequency of the process, and then speed. So start and stop frequency is 1 GHz and to 12 GHz of the process. So these are the overall design of the antenna design, and then to click the, so this is the validation checkbox, so I will click the validation checkbox, the design setting, 3D model, boundaries and excitation, mesh operation, analysis setup, optometrics and radiation button. So all are, it should be correct, so only it will be displayed in the green tick. And then this is the running process, so analysis or overall the running is running, so it takes some time to run the process, and then it should be shown, finally get the result of the process. Yeah, here we using, this is the return loss of the antenna, and then by using whatever it may be, I will click that. So this is the radiation pattern, so I will click the radiation pattern, it should be the radiation pattern of the antenna. So HFSS results, create terminal solution data report, rectangular report, so I will click the new report, it should be displaying the radiation return loss of the antenna, and then similarly the same process, and then far field we take the data table, so that is the data table which should be displayed. So whatever it may be, return loss, it should be displayed. So these are the multiple frequency of the antenna. So here one antenna, here this one, below minus 10 dB, all the frequencies are uptime, the multiple frequency of the process. So these are the different types of return loss to take in the process. So these are the overall running procedure for the product. Thank you for listening this video.